The first problem that we are going to look at for binary search is this problem that I call the flight path problem. Let's understand the problem statement and then we'll come back and look at the solution. So here we have an aeroplane that takes off from an airport and, as you know, steadily gains height. The aeroplane's altitude is being logged in the flight data at regular intervals, perhaps could be 1 second, it could be 1 millisecond or something like that. We have a student of aviation who's studying this data and wants to understand the time at which the plane crosses a certain altitude. We need to come up with an efficient algorithm for this purpose. So basically, this data of the flight's altitude is being logged in the flight recorder. The student looks at the entire log of data. Maybe it could be a million points, lots and lots of points. And from there, the student wants to find out when is it that the first time plane went above a certain height. Let's see this from numbers. So perhaps let's say the altitude is starting at 0, say 12. Now this could be arbitrary units. It could be, let's say, some units, it could be meters perhaps, right? So I have this, for example, this list altitude, which is, notice, a non-decreasing list. So it's sorted in some sense. Like for example, here I have 36 and 36, but there's no point where the plane altitude drops. So that's an assumption in the problem, that this list is sorted. This list is, let's say, non-decreasing. Now the task we have at hand is the first time instant. So this is, like I said, at regular time instances, could be 1 second, could be 5 seconds, whatever. The first time instance, basically the first index where the altitude becomes more than, for example, 50. Now in this case, the answer would be 10, because look, 53 and 48. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So altitude 10 is 53, which is more than 50, whereas altitude 9 is 48, which is less than 50. So basically, the first time that we measured a height or altitude more than 50 was indeed at index 10. So that's what we are looking at, the first instance where the altitude becomes more than, let's say in this case, 50. A couple more assumptions about the data. The extreme values, we are going to assume that altitude 0 is always 0, which is reasonable because the flight is taking off. So at the beginning, it's at the ground, altitude is 0. We also assume that this threshold is strictly positive. So I'm whatever threshold is this number here. Well, it's always, let's say, more than 0, right? And why is this significant? Because what this means is that, look, at 0 we will never have the threshold being exceeded, because the threshold is strictly positive and the first altitude or 0th altitude, let's say, is 0. So at 0 index we'll never have the threshold being exceeded. However, there is a possibility that the threshold may be higher than all the values, which is altitude n, for example, in which case the function should return -1. So it's like telling that, look, I looked through the entire list of altitudes and I did not find any place where the plane went higher than this height. Basically, that's the sort of problem statement. And of course, in this, I'm assuming that the altitude has, let's say, n+1 value. So here's the, fairly, let's say, straightforward problem. The idea is that we have a list of numbers. We must find out where does the first number which goes above a certain, let's say, threshold exist. In the next couple of videos, we'll analyze this problem in more detail and then write code using binary search to solve this problem. Do look at our website www.ybyte.in for more such videos. Take care and enjoy coding.